So we saw how wave pulses interfere with each other. We should have seen that as a pulse moves this way, if I've got two pulses in the same direction, when they meet, they make one bigger pulse. The energy adds up. And then after, I've got them back, just going in opposite directions. So we should have noticed that. And we should have noticed that if I have a wave pulse like this on top and then a wave pulse on bottom, traveling towards each other, when they meet, they flatten out. And then after they pass each other, well, then we've got the one on the bottom and the one on the top. After they pass each other, this one is going this way and this one is going this way. So we should have seen that. This is called wave interference. This is constructive interference. So it's constructive. It creates more. This is destructive interference. So it breaks it down. Now, why do I talk about that? Why do we care about this interference? Well, most of the time, these waves aren't just moving in a single pulse, right? If we look back at that wave on a lake, that's not moving just in one pulse at a time. That's continuously moving back and forth. As that water level tries to even back out, it keeps sending out new waves. So this is really uncommon. What we're more likely going to have is I've got the spring here, so looks like that, and I'm going to move it back and forth continuously. So back and forth, so just back and forth. So I'm going to continuously send wave pulses down it. So just constant wave pulses going down it. And what's going to happen? Well, at first, we're going to get a lot of weird kind of random motion. Because what's going to be happening is these pulses are going to be doing constructive interference and destructive interference just all over the place. But there's going to be a certain point where all of that will even out, and all of my constructive interference will be right in the middle. All of my destructive interference will be right on the edges. And what I'm going to get is the first part of a waveform, and it'll look like just moving back and forth like this. It'll really look like a jump rope. And so we're going to get to this point first. I'm going to show you that. Then after that, I'm going to keep going. I'm going to turn up the speed. I'm going to start moving this back and forth faster, just going faster and faster. And what we're going to start to see is it'll get really chaotic again. It'll be kind of hard for me to keep it going at that chaotic rate, but eventually I'll start to have all of my interference, all the destructive interference happening right in the middle and on the two ends. Then all of my constructive interference will happen at these 2 points. When I start to move it at the right speed, which is the frequency, remember that how quickly I'm moving it back and forth, that is the frequency. If I move it at the right frequency, I get this shape, this waveform shape. And we'll be able to see that. It'll be back and forth. It looks really cool. And if I keep going, I can progressively get more and more shapes. So I got 2 humps here. I could get 1, 2, 3. I could get 1, 2, 3, 4, so on and so forth. These different wave shapes have a special name. They're called harmonics. And they're called harmonics because they have a lot to do with melodies and harmonies in music. So when I say harmonic, what I'm saying is this would be our fundamental harmonic, our first harmonic. This would be our first. This would be our second, third, and fourth. And what's happening here is these frequencies would all be doubled. Now this is important, especially in something like music. Because if, let's say this is a string. This is a stringed instrument like a guitar. We'll look at those later. But if this is a stringed instrument, and this is a guitar, let's say this is a G note. Just a regular G. So that could be something like, the lowest G I think is around, gosh, I don't know, I think it's around 60 some hertz. But let's just say it's 60 hertz, just for the sake of argument. So if this is a G at 60 hertz, well, the second harmonic would be 120 hertz and would be the next octave up. If you don't know anything about music, that's okay, you can kind of skip this part. But anyone who does have an idea about music, anyone who plays a musical instrument, this would be the next G up. So this would be a note much higher. This would be a full 12 notes higher than this note. This is actually a big part of how these instruments work. They use these harmonics to have separate octaves, and all of these notes can merge and work together and result in some very pleasant melodies. So let's take this to our spring, to our little wave demonstrator, and take a look at how did these things move? How do they get created? Because the spring is nice and long, we're going to be able to see a really good, nice, slow example of what these look like. But on an actual stringed instrument, the frequencies are in the hundreds and 200s of times per second. So it's going to be really hard to see that on a string, on a stringed instrument. But it's going to be really easy to see it on our spring. So let's go take a look.
All right, so we're going to try and make the first 5 harmonics here. First one's really easy. It's just a back and forth, just like if you were playing jump rope. Anyone who's played jump rope knows that as you get to this harmonic, as you get this spring moving the right way, it kind of just keeps pulling you along. It's really easy to maintain. It's tough to get it up to the next bit, but once you reach that state of harmony, so here we've got the second harmonic, it's just pulling my hand back and forth, and it's really easy to keep it in that shape. But to try and get it to go faster, and we can see here it's becoming very chaotic all over the place, it gets really hard to get it going. I even had to stop and restart. I'm trying to reach the third harmonic here, and you can see I'm failing. I skipped right past it, went to 4, so you can see I've got 4 little humps in there, 4 back and forths. And again, it's more difficult because you're fighting the resistance. We've got that interference between these waveforms. I'm just sending constant pulses. So I've got the second harmonic here. I've got the 2 bits going back and forth. And now finally I get the third. So we can see I've got 3. 1, 2, 3 waves going back and forth. And so again, this is easy to maintain, but it's hard to get it to go faster because you're now fighting against this harmony. So it just gets really chaotic when you're in between these waveforms, but then suddenly order out of chaos. We've got 4 humps now. Now I'm trying to go up to 5, and I think I got it for a second. This is just me trying to go faster and faster, and it's starting to get chaotic, and then... Do I get it? No, I had to stop. Let's try again. Chaos, chaos, chaos. And order. And there we go. We've got 5. 1, 2, 3, 4, 5. But then we fell right back down into 4. It's easier to maintain a 4. It's easier to go at that speed.